Hello everyone, in our last few videos we saw type 1 to type 5. In this video we will be seeing type 6, which is basically integration by parts. So let's get started. Here we will basically be seeing the application of this formula, which is integration of u v dx equal u integration of v dx, then minus whole integration of d dx of u, then integration of v dx. So let's start number 1. You will do number 2 and 4 and I will solve the rest. So in number 1 we have integration of x e to the power x. So let us consider this x as our u and e to the power x as our v. So according to this formula, first we have to write u. So we wrote x. Then we have to write integration of v. Our v is e to the power x, so we wrote integration of e to the power x. Next we have to write minus whole integration of d dx of u. So we wrote minus integration of d dx of u, which is our x. Then we have to write integration of v, and v means our e to the power x. So we wrote integration of e to the power x dx. Now we will just calculate. So since we have x at first, so we wrote x. Then we have integration of e to the power x, which gives us e to the power x. So we wrote e to the power x. Then we have minus whole integration of d dx of x. We know d dx of x gives us 1, so we wrote 1. And integration of e to the power x gives us e to the power x, so we wrote e to the power x. Since it is multiplied by 1, so we wrote e to the power x. And rest part is remain same. Integration of e to the power x gives us e to the power x. So our final answer is x e to the power x minus e to the power x plus c. If you want, you can take e to the power x as common here. So let's move to our next example 3. In number 3, at first the formula is written. Now the question is integration of log x dx, where we have to apply this formula. Since we don't have anything as our v, we can consider 1 as our v. So now we have log x as our u and 1 as our v. So according to this formula, first we have to write u. U means log x, so we wrote log x. And then we have to write integration of v. V means 1, so we wrote integration of 1 dx. Next, minus whole integration of, we have to write d dx of u. And u means log x, so we wrote d dx of log x. Next we have to write integration of v dx. V means 1, so we wrote integration of 1 dx. 1 is not written here. Next, log x is written again, and integration of 1 gives us x, so we wrote x here. Then minus integration of this inside part. The inside part gives d dx of log x, which is 1 over x. This is the 1 over x. Next, integration of 1 is x, so we wrote x. This x and x can be cancelled, so we have 1. In the next line, we wrote log x into x as x log x, and integration of 1 gives us x. So at last we have x log x minus x plus c. Your task is to solve number 2 and number 4. Next, move to our number 5. Here in this problem we have to integrate x square cos x dx. Now to apply this formula, let us assume x square as our u and cos x as our v. So according to this formula, first we have to write u, so we wrote x square. Next we have to write integration of v, so we wrote integration of cos x, which is our v. Then we have to write minus whole integration of d dx of u, so we wrote d dx of x square, since x square is the u. Next we have to write integration of v, and v means cos x, so we wrote integration of cos x. Now x square is written as it is, and integration of cos x gives us sin x. Now minus integration of d dx of x square, which is equal to 2x, and integration of cos x is sin x. Now we took this 2 in the left side of the integration sign, and we have to apply the uv formula again in this part. Since we have now u and v here, we have x and sin x, so we can assume x as our u and v as our sin x. So we wrote x square sin x as it is and minus 2. Then we applied the uv formula in this part. First we wrote u, which is x, then we wrote integration of v, which is sin x, minus integration of d dx of u, which is x, and then integration of v, which is sin x. Next we wrote x square sin x minus 2 into x, then integration of sin x is minus cos x, then minus integration of d dx of x, which is 1, then integration of sin x, which is minus cos x. Now we are multiplying the things we have before the brackets, so let's do that. X square sin x is written as it is. Now we have minus 2, so we multiplied this minus 2 and x with minus cos x. So we got minus minus plus 2x cos x. Now we have multiplied this minus 2 with this minus and this minus with this cos x. So we got minus 2 into this minus cos x. So we got minus 2 into integration of cos x. Now integration of cos x gives us sin x, so we wrote sin x and rest of the part is as it is. Later we wrote this part in the right side and this part minus 2 sin x in the left side, so that we can take common sin x. So in the next line we took sin x as common, so we got x square minus 2 into sin x plus 2x cos x plus c. So that's the answer. Let's move to number 6. In our last example, we have integration of x square tan inverse x. Let us consider the first part x square as our v and the second part tan inverse x as our u. So according to the formula, first we have to write u, so we wrote tan inverse x. Next we have to write integration of v, which is x square. Next we have to write minus integration of ddx of u. U means tan inverse x, and then we have to write integration of v, which is x square. Later we just applied the normal formulas, which is integration of x square gives us x cubed by 3 and tan inverse x is written as it is. Next we have written minus integration of the inside part. ddx of tan inverse x gives us 1 over 1 plus x square, and integration of x square gives us x square over 3. Then we just arrange this part a bit. We wrote tan inverse x cubed by 3 as 1 by 3 into x cubed tan inverse x. Also we brought this constant part 1 by 3 in the left side of the integration part. In the numerator we have x square and in the denominator we have 1 plus x square. We wrote this x square as x into x square. Why? Because we have 1 plus x square in the denominator. So we want to bring the same thing in the numerator so that we can cancel it out and reduce these things. So in the next line we wrote x into 1 plus x square minus 1 in place of x square. So we wrote an extra 1 here and here so that we can match the numerator with the denominator after separation and we can cancel it out. So in the next line we just separated the two parts, so we wrote 1 plus x square over 1 plus x square minus 1 by 1 plus x square. So this 2 can be cancelled, so we wrote 1 and right side is as it is, and in the left part it is as it is, so I have not discussed it. So we have written again 1 over 3 x cubed tan inverse x minus 1 by 3. Then we just multiplied this x with the inside things 1 and 1 over 1 plus x square, and also we multiplied this 1 over 3 with the parts inside the bracket. So we got 1 over 3 integration of x plus 1 over 3 integration of x over 1 plus x square. Left part is written as it is. We just integrated this x, so we got x square over 2, and in the right side we brought an extra 2 here. Why? Because we want to apply a formula which is ddx of f1x over f of x equal to log of f of x. So for using that formula here we wrote an extra 2 here. Why? Because here f of x in the denominator is 1 plus x square and differentiation or first derivative of this is 2x. So we brought 2x in the numerator. For bringing the 2x we brought an extra 2 here. Now we can apply that formula ddx of f1 of x over f of x equal log of f of x. So from this we can write log of 1 plus x square, since 1 plus x square is the f of x, and we have just multiplied the 3 with 2, so we wrote 6 here, and rest part is as it is. We have not changed that. So finally our answer is 1 over 3 x cubed tan inverse x minus 1 over 6 x square plus 1 over 6 log 1 plus x square plus c. So that's the answer. Thank you.